Good morning, kids. Welcome back. It's Monday, May 4th. It's May. Can you believe that? We have 3 weeks left of new material for digital learning. 3 weeks, that's 9 lessons for me. And I have to cover all of space. So I'm in kind of a tough spot here, in that I would love to take 3 months with you to study this or 3 years. Uh, we don't have that. So I'm going to go over some stuff that is the most important information about space. And that's about the best that we can hope for given our circumstances this year. So hold on tight. We are about to take off. And today we are going to take a beginning look at the solar system. So if you follow along with me in chapter 24, which I shared with you, or you can just follow along on the screen, we're going to go over some of those main things. So as we scroll down here a little bit, first off, there were some early ideas about the solar system, and we should be very clear about what a solar system is. Our solar system is the sun and everything that is associated with the sun, or everything that travels around the sun is our solar system, which is more than you probably know. But people didn't always think that. In fact, early on, people assumed that the Earth was the center of the universe. Everything revolves around the Earth. And it does make sense when you look up at the clouds. They appear to go around the Earth, which they do, by the way. When you look at the sun, if you were to stand and kind of with protective eyewear and watch the sun all day, it appears that the sun goes around the Earth. If you really paid attention to the stars at night, it would appear that they rotate around the Earth. So it was very difficult to disprove that theory, and that theory hung on for many hundreds or thousands of years, that the Earth was the center of the universe. Fortunately, as some technology started to be developed, some new ideas, some new thinkers, like Nicholas Copernicus, he came up with the idea that, the sun is not necessarily, the Earth is not the center of the solar system, but the sun is. And that took observations by using telescopes that eventually Galileo had invented, to look at different planets and their motions. And the bottom line is this, that when people started to look at these planets and their orbits, the math just did not work in order for the Earth to be at the center. Because if the Earth was in the center, some of these planets would actually have to stop in their orbit and go backwards. And there were just some really crazy mathematical things that didn't make sense if the Earth was in the center. So when they moved the sun to the center of the universe, the sun, the center of our solar system, then things started to make sense. All right. And so now we've got this modern view of the solar system with the sun in the center. And then we've got all of the planets that you should be familiar with: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Pluto was still in our book. It was published in 2006. At that time, Pluto was still a planet. Pluto is still there. It's just considered a dwarf planet. And there are several other dwarf planets in our solar system as well. So when we discuss the information in the book, it's still going to show Pluto as a planet. Technically, that's not the case anymore. Along with the planets, we have all of the moons of the planets. We have asteroids. We have comets. We have meteors. And obviously, I had said earlier, dwarf planets. So lots of stuff in our solar system. And all of it orbits around the sun. How did the solar system form? Now, this is some very technical stuff, so I'm going to break it down into very simple terms. I know I may not answer all of your questions about it. Feel free to research it more on your own. But I'm going to scroll down to this picture. This is called a nebula. and these exist out in the universe. They are extraordinarily huge, and they are filled with gases, ice, those kinds of things. And what happens sometimes is usually because of an explosion nearby of an exploding star or something like that. It causes this gas to contract. And when those gases contract, they can, their temperature goes up. They can then become a solid. They can then, gravity will take over. And as these things collide with other little pieces within the nebula, get bigger and bigger and bigger. And the larger something is, the more gravity it has. And so it pulls more things towards it. And that's kind of the basics of how it gets started. There's a little picture here that shows kind of a starry nebula, and then we have this flattening of the disk as it starts to heat up. It spins in a disk. The larger parts that I talked about start to clear out the other things in their orbit, and eventually we end up with planets, moons, and in the center, a star. Don't forget, that's what our sun is. Our sun is a star. If someone asks you what's the closest star, you better say the sun. All right. So that's in general how a solar system forms. By the way, there are billions upon billions upon billions of stars in the universe, which means there are billions and billions and billions of solar systems. There are billions of planets that are out there. So our solar system really isn't that special, other than it happens to have one planet on it that the conditions are correct for us to survive. All right. So that is in general how a solar system or our solar system forms. This last little bit, Copernicus and then eventually Kepler studied these motions of the planets, and eventually they were able to track how fast they move, and how long it takes them to orbit the sun, and therefore how big their orbits were. Also, the shape of their orbit. Copernicus thought they were all just perfect circles around the sun, which is not true. They're ellipses, so think like ovally shape. All right. So at some points in the orbit, planets are closer to the sun. At some points, they're further away from the sun. Speaking of that, so what do you think? Summer versus winter on Earth. Which one of those two seasons here in the Northern Hemisphere do you think we are closest to the sun? Would we be closer to the sun in summer or closer to the sun in winter? I'll give you 5 seconds. Well, I'm guessing that a lot of you were wrong. The truth is, planet Earth is closest to the sun in January, and we are furthest from the sun in June. I know, it's wild, but here's what you need to understand. Our seasons and our temperature here in the Northern Hemisphere don't have anything really to do with how close we are to the sun. It has to do with the tilt of the Earth. Are we tilted towards the sun so that we get more direct sunlight, which we are in June? Or are we tilted away from the sun where we get less direct sunlight, like we are in January? So even though we're closer in January, we're tilted away from the sun, which means we get less direct sunlight, and it's cold here. I know, wild, weird stuff. Now, along with that, we're going to just very quickly buzz through some key points on the inner planets, the 4 planets that maybe you're most familiar with, starting with Mercury, the closest planet to the sun. Mercury is very small. On the portion of the planet that is facing the sun, it's extremely hot. It has very little atmosphere. In fact, it's said to have no true atmosphere. There are a few gases floating around. It's not habitable. Things can't survive there, probably. at least that we know of. Lots of craters, lots of impact craters that you can see kind of a little snapshot here in this picture. The sun, because it's so large, it has the most gravity and it pulls everything towards it. All right. So asteroids, comets, those kinds of things are all heading towards the sun. And unfortunately for Mercury, being so close to the sun, it gets in the way a lot. And so lots of collisions happened early on in Mercury's formation to give it all those craters. All right. So very hot. Next, moving away from the sun, we have Mercury, and then Venus. Venus is a planet that is very similar in size to the Earth. It's much closer to the sun than the Earth is. But Venus is extra special in that it shows what happens when the greenhouse effect goes crazy. Venus had lots of active volcanoes, which spewed out lots of carbon dioxide and completely filled its atmosphere with carbon dioxide, and so heat can't escape. Venus is in the neighborhood of 800 or 900 degrees all the time, because any of the light from the sun makes it through the atmosphere, is converted to heat, and that heat is trapped inside that thick blanket of atmosphere, that thick carbon dioxide atmosphere. So Venus, it also has a very high pressure at the surface. We've sent some space probes there and tried to land on Venus, and basically they get crushed after a very short period of time because the weight of the atmosphere is just too much to, for any of the stuff that we can build to get there. Also, that atmosphere is very nasty. We can't breathe it, and it does corrode things as well. So Venus, very neat, but very dangerous, very deadly, and very hot. Earth, now we spent 6, 7, 8 months studying the Earth, so I'm not going to talk much about the Earth. The main feature that we can see on Earth from space would be water, and that's what separates Earth from all of the other planets that we're going to study. And finally, the last planet that we'll look at today is Mars. Mars is the most interesting to us. It's not nearly as big as the Earth is. I know often I picture it in my head as being about the same size, but it's quite a bit smaller. But it has some really cool features. It does have ice on its poles. Mars is tilted on an axis, so it does have seasons. So some of that ice melts or refreezes depending upon the season. So much like Earth, it does have those polar ice caps. It has the largest volcano in the solar system, Olympus Mons. It's got this huge valley that is way bigger than the Grand Canyon. So it has lots of surface features that are familiar to us here on Earth, but really on steroids, like huge, big, massive, dangerous features on Mars. It is also by far the most explored planet that we have. There are a couple of orbiters cruising around on it right now. I recommend you search for Mars Curiosity. It's about a small vehicle, small car-sized vehicle cruising around, digging holes, doing tests on Mars right now. And we've had a few of those rovers, lots of other landers and space probes that have checked out Mars. So we are learning more and more about Mars all the time. Hugely cool. Do a little bit of research on what we know about Mars, and I will probably point you in a few directions to check some things out. All right. So with that looks like we'll touch briefly on Mars's moons. It has 2 moons, Phobos and Deimos, and really they are just little dinky, oddly shaped rocks that probably were pulled from the asteroid belt. The asteroid belt is between Mars and Jupiter. A couple of these large-ish asteroids, but very small moons, were probably pulled into orbit around Mars. And you can see they're also cratered up. Any of these surfaces that don't have weather, show all of these crater features. That's why our surface doesn't look like that, because we have weather. We have weathering and erosion, and it breaks those things down over time. We do have a few large craters that are still visible, but all the small ones pretty much get covered with vegetation, or these asteroids hit the water, those kinds of things. So that's why our surface doesn't look the way that these other planets do. So, with that said, that is a brief introduction to how the solar system formed and the 4 inner planets: Mercury, Venus, Earth, and Mars. Take the very short quiz that goes along with this, and tomorrow we will take a look at the outer planets. And I will try to do my best to keep the Uranus jokes to a minimum. All right. So, with that, I will talk to you tomorrow.